The objective of this lesson is to build larger fractions made from copies of unit fractions for fifths, tenths, and twelfths using area and linear models. In third grade, students worked with denominators 1, 2, 3, 4, 6, and 8, practicing iterating unit fractions with number lines and area models. Now in fourth grade, students will continue to use both models, but with denominators of 5, 10, and 12. What is a unit fraction? 1/2 is an example, as is 1/3, 1/4, and 1/5. A unit fraction is where one piece of the equal-sized pieces is being considered of the whole. For 1/2, one piece out of two equal-sized pieces are needed to create the whole. Let's use Cuisenaire rods to model unit fractions and larger fractions. Let's use the orange rod to represent the whole. Let's use the white cube to model a unit. How many units does it take to make the whole or orange rod? If we line them up, it looks like it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 1/10 units to make the whole. What is the value of one cube in relation to the rod? The white cube is one of the 10 total cubes, so it is 1/10 of the whole. How could we model 3/10? If we line up our units, that would be 1/10, 2/10, 3/10, or 3 iterations of 1/10. 3/10 is 3 1/10 units being counted, and it takes 10 cubes to make the whole. How could we model 5/10? We line up our 5 1/10 units, 1/10, 2/10, 3/10, 4/10, 5/10, or 5 iterations of 1/10. 5/10 is 5 units being counted of the 10 1/10 cubes it takes to make the whole. How do we model a fraction greater than 1, such as 16/10? We know that the orange rod is made of 10 white 1/10 unit cubes, and it would be 6 more unit cubes. 11/10, 12/10, 13/10, 14/10, 15/10, 16/10. We can also use a number line to model fractions. Let's start by making a number line using the edge of the orange rod. Now, let's use the unit cube to mark off tick marks starting with 0 and extending further. Let's mark our tick marks 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. To show 3/10, we make jumps along the number line, 1/10, 2/10, 3/10. How would we model 5/10? We make jumps of tenths, 1/10, 2/10, 3/10, 4/10, 5/10. Now let's use the yellow rod as the whole. How many units does it take to make the whole? It looks like it takes 5 unit cubes, so there are 5 1/5 to make the whole. How would we represent 3/5? This would be 1/5, 2/5, and 3/5. 3 being the numerator, or number of units counted, and the denominator means how many times the whole is shared or divided up equally. Let's line up an orange rod and a red rod as the whole. How many units does it take to make the whole? It looks like it takes 12 unit cubes. There would be 12 1/12 cubes to make the whole. What fraction would just 4 cubes represent? This would be 1/12, 2/12, 3/12, 4/12. 4/12 shows we counted 4 1/12 units, our numerator being 4, and our denominator of 12 represents how many equal pieces make the whole. Your child will continue to explore fifths, tenths, and twelfths using Cuisenaire rods and number lines and find and record examples they find in and out of their classroom. The objective for this lesson was to build larger fractions made from copies of unit fractions for fifths, tenths, and twelfths using area and linear models. We met this objective by using manipulatives and drawn number lines to create models and fractions and deepen their understanding of numerators and denominators.